Welcome to another lesson today that we are going to discuss. In this lesson, we are going to discuss a very important component of multiplying actually vectors. As you may be aware, previously we looked at multiplication of vectors using the dot product. And so there are many methods that can be used to multiply vectors. But I'm just going to look at two methods, the dot product as well as the cross product. And so it's important that people who are doing physics understand the use of the dot product as well as the cross product to multiply vectors, because several times we interact with the problems which require us to use actually certain methods to multiply vectors. And so it's important that people understand the use of the cross product that we are going to discuss today. And so here we go. Actually, as I indicated earlier, today we're looking at the cross product or the vector product. And so the vector product or the cross product, as it may be called, is one method that helps us to multiply vectors. For example, if we have two vectors, A and B, which are non-zero, and we want to get their cross product, all we do is to find the magnitude of one vector as well as the other vector, and then you multiply it with sine theta and multiply by n. Okay, and so n here represents that it's a unit vector which is perpendicular to both vectors A and B. And so therefore, it's important to know that normally the angle between the vectors, when you are using the cross product between the vectors, that is, for example, vector A and B, should be actually greater than or equal to 0, or it should be less than or equal to 180. And so, as we stated earlier, therefore, if the angle here is 180 for parallel vectors, it means that we're going to have sine 180. And sine 180, we know that it is 0. And therefore, the cross product of parallel vectors is 0. So if you have two vectors, A and B, and you want to get their cross product, it should be equal to 0. Similarly, if, for example, the angle between the two vectors, A and B, is 90, it means that we are going to have sine 90, and you know that sine 90 is 1. And therefore, the cross product of A and B will be equal to the magnitude of A multiplied by the magnitude of vector B. And so where we are going now is very, very important. I want to reemphasize that most people have a challenge in solving problems using the cross product because they miss these important concepts of actually understanding the cross product of unit vectors. And so the cross product of unit vectors, for example, I and I, the cross product would be 0 because these vectors are parallel. Similarly, for J and J, the cross product of J and J would be 0 because these actually vectors are parallel. Similarly, K and K, the cross product would be as well 0 cross product of k would be k and k would be 0. It is also important to know that if you multiply the cross product of I, you get the cross product of I and j, you get k, positive k. And if you get the cross product of I and k, you get negative j. If you get the cross product of j and I, you get negative k. And if you get the cross product of j and k, you get I. If you get the cross product of k and I, you get j. Also, if you get the cross product of k and j, you get negative I. So it's important also to understand the properties of the cross product. The distributive properties of cross product are such that, for example, if you want to get the cross product of A and B plus C, is such that you may get the cross product of A and B, and then you add it to cross product of A and C. That is if A and B and C are vectors. Similarly, if you have a scalar beta and you multiply it with a cross product of A and B, all you do is you multiply that scalar or that number multiplied by the cross product of A and B, which would be also equal to the cross product of A and B multiplied to the scalar. The component form of cross product is very important as well. So, for example, if you have two vectors here, vector A, which is AXI plus AYJ plus AJK, and another vector component, which is BXI plus BYJ plus BZK. So you have these two vectors and they are in the component form. And so you want to get their cross product. All you do, you merely make a matrix so that you can get actually a determinant. So the cross product of A and B would be, you make a matrix the way this one is presented. And therefore, the cross product of A and B would be actually similar to the cross product of these two components, component for A as well as the component for B. Okay. And so if now you want to expand, you expand, what it means is that you multiply AXI multiplied by BXI. So AXI multiplied by this, it means that I would multiply the I, you would get the cross product of I and I. Similarly, when you multiply IXI multiplied by BYJ, and so what you get is this. It means that you are going to get AXI BYI cross J. Plus, similarly, if you multiply AXI multiplied by BZK, it means that now we're getting the product, the cross product of I and K. And therefore, this is what you get here. Similarly, you can expand further now, you multiply this AYJ with everything, as well as you multiply AZK with everything here. So what you will get are these. And remember, we looked at the properties of the cross product. We said the cross product of I and I will be 0. So this one becomes 0, as well as J, the cross product of J becomes 0, as well as the cross product of K and K becomes 0. And therefore, we eliminate, as I indicated here. It means that in that equation, this equation which we found here, we have eliminated this. We have eliminated this one as well as this one, because they are 0, as we have indicated here. And so also we remember we said that the cross product of I and J will be K, and the cross product of J and K will be I, and the cross product of K and I will be J. So here, where we have I and J, we can replace with the K. And here, where we have J and K, we can replace it with I. And similarly, here we have K and I, we can replace it with J there. And so after substituting that, this is what we find. So we are going to find here, there will be K now. We are going to have AX, BY, K, because we have replaced the cross product of I and J with K. Okay, and so if we rearrange these terms, then this is what you get. It means that we're going to get AY, BZ minus AZ, BY, and all this multiplied by I minus A, BZ minus AZ, BX, everything multiplied by J. Similarly, and plus AX, BZ minus AY, BX, all multiplied by K. And so, remember earlier on, we represented the cross product with a matrix like this. So in other words, where the cross product is merely getting the, as I indicated earlier, you get the determinant. For example, when you are dealing with the I for this one here, you have to get the determinant. You'll be dealing with this matrix here. So that's why you find here there is AY, there is AZ here, there is BY, and there is BZ, which is this one here, and multiplied by I. Minus, if you are dealing with the J, it means that you'll be dealing with this determinant, which is AX and AZ, and you have BX and BZ. So all these will be multiplied by J. If you are getting the value for K, it means that you have to get the determinant of this one here. So you're going to have AX, AY, BX, BY, all multiplied by K. And so here is the question now to explain or to illustrate further the concepts that we have learned, and we see how we can apply them. And as we have seen, this has been simplified. It's a very, very simple concept, and I don't expect students to have problems with this. So for example, if we have two vectors A, 2i minus j plus 3k, and the other vector B, which is 3i minus 2j minus k, and we are told to calculate the cross product of A and B. So the first solution, if you are to use the matrix form, you rearrange. So you start with A. So A would be this one, 2, -1, and 3. And your B would be 3, -2, and -1. And therefore, you get now the determinants as we indicated of this. So you can get for I here, it means that you are getting the determinant of this part here. So you are going to multiply -1 times -1 minus -2 times 3, which is here. So you're going to have -1 multiplied by 1 minus 3 times 2 multiplied by I. Similarly, for you to get the value of j, you're going to multiply 2 times -1 minus 3 times 3. It means that you are getting the value for, so this is what it is here. We are multiplying 2 times -1 minus 3 times 3. You get j there. Similarly, if you are to get the value for k, it means that you have to get the determinant for this one. So it will be 2 times -2 minus 3 times -1. And this is what is here. And what you get as the cross product of A and B is when you get the solution here, you get 7i plus 11j minus k. Another simple question, calculate the cross product of, actually here I meant B, I meant the cross product of B cross A, which is the opposite of the previous one. So all you need to do is to rearrange. Remember this one started with A. And this other one now, we are going to start with B. So this equation for B, and this is the equation for A, as you can see from here. So we have started, this was the equation for A, the first one, then this one was the equation for B. Okay, so now we have said we find now the cross product of B and A, and therefore you start with B here and then A. And so all you need to do is you get again the determinant of this. So for this one here, what you are going to do, if you are getting the value for I, you are getting the determinant for this part here. So we are going to multiply -2 times 3 minus 1, -1 times -1. So this is the part here, -2 times 3 minus -1 times -1, and all is multiplied by I. If you are getting the value for j here, it means that you have to get the determinant of this matrix and this one. So it means that you multiply 3 times 3 minus 2 times -1. So this is 3 times 3 minus -2 times 2. And this will be multiplied by j. Similarly, if you are to get the value for k, it means that you have to get the determinant for this part. So it will be 3 times -1 minus 2 times -2. And so what you get is the opposite, is -7i minus 11j plus k. And you notice that actually this is opposite of what we found here. And so it means that actually the cross product, if you are getting a cross product of A and B, it is not the same as the cross product of B and A. It means that the other one would be negative. And so this is actually what today we wanted to illustrate. We wanted to illustrate how we can actually get the cross product of vectors, which is very important in physics. And so we end the lesson here. We hope that we can meet for another lesson next time. please remember to subscribe to my YouTube so that you continue enjoying these lessons. Thank you.